Bismillah. Now we are going to answer this question about this lesson, okay, which is called solution. Okay.
Okay.
Try to answer the first question. Okay, Mariam.
Okay. Water vapor and air is a gaseous solution of kind liquid in gas.
Liquid in gas. Okay, this is the answer of lesson one, which is called solution and colloids, right?
Yeah. Yes.
Right, it's okay. So question number one, water vapor in air is a gaseous solution of kind what? You said
Liquid in gas.
liquid in gas, right. Number two,
The measure of the angle between two bonds of water molecule equal 104.5.
number D, right. Number three,
Number three is from strong electrolytes. Number C, HCl, but aqueous. I mean number D, sorry.
yeah, number D, not number C. Number C as a gas can't
Yes,
be electrolyte.
yes,
So it's number D that can be electrolyte
yes.
HCl in aqueous solution. Okay, right. Number four,
Okay. The measuring unit of molality is mole per kilogram.
right. Why molarity?
Mole per liter.
Right, right. Question number two. What's meant by solubility?
Okay. Sorry. Here. Give me a second to just
Yeah, yeah,
get
yeah.
the.
Okay.
Okay.
Take your time. Take your time.
It's the mass of solute dissolving in 100 gram of solvent at certain temperature.
Right. It's solubility. Okay. Number two, saturated solution.
Okay, wait. Saturated solution.
Do, do you save it or no?
Yes, I saved it, but I don't remember in what page.
Yeah, okay. Okay. I think if you save it, you can say it without searching for your homework.
Okay, saturated solutions are the solutions that doesn't allow the dissolution of any amount of solute inside it.
What? Again, the last part.
Okay, yes, it's here. Saturated solutions, they are the solutions that doesn't allow the dissolution of any additional amount of solute without a change in temperature.
Right, right. By this way, but I think the first
Yep.
one, I think it has a mistake. The
I
first
didn't say
definite.
I didn't say the temperature.
Yeah, it's a very important condition at a specific temperature because if you increase the temperature, saturated solution will change into super saturated solution. So you must say
Yes,
this word as a specific temperature or without being changed in temperature, right?
right.
Okay. Also meant by boiling point.
The temperature at which the vapor pressure of solution becomes equal to the atomic pressure.
Yeah. To atomic pressure. Okay. Right. Question number three about the problems. Number one.
Yes. Number one, I will get the percent of concentration, which is by the mass of solute over mass of solution. It will be 100 times 10 over 240. So it will
Right.
be 24%.
Right. It's very simple. As percent concentration equal mass of solute divided by mass of
Yes.
solution times 100. So it will be 10 divided by 240 and the product multiplied on 100 equal 24%. Right. Question number 2.
Yes. The volume of solution will be the volume of solute plus the volume of solvent.
Right. It's the volume of solution as the first. So it will be what?
Yes. It will be 25 plus 50 equals 75 milliliter.
So it's a volume of
Then I
the
will get
totally
the
solution.
concentration.
75 milliliter. Okay. So after that,
Then I will get the percent concentration.
yeah, how to get it?
It will be 100 times 25 over 75, the volume absolute over volume of solution. It will
Right.
be 100, it will times by 100, it will be 33.33%.
Right. 33.33 per percentage. Right. Question number 3.
Question number 3, I will get the molar mass of sodium hydroxide. uh, 23 plus 16 plus 1, it will be 40 gram.
Right. It's a
Then
molar mass of
then
sodium hydroxide. So after that,
yes, then I will get the number of moles in 20 gram of sodium hydroxide. It will be 20 over 40. It will be 0.5 mole.
right. It's okay. So after that,
Then after that, wait, yes, I will change from milliliter to liter.
right. Because the volume must
It's
be
the
by
same.
liter. So molar
Yes.
concentration equal what?
The molar concentration is the number of moles of solute over the volume of solvent. It will be 0 0.5 over 0 0.2 equal 2.5 mole per liter.
Per liter because it's a volume of gas as molality. Okay, right, Mariam. Right, excellent. Okay, so after that, determine the type, determine the type of colloidal system with the following. Mayonnaise.
Yes. Mayonnaise,
So
first the medium
it's
of
yeah,
dispersion.
it's an medium of dispersion and dispersed substance. What's the medium
The medium is liquid,
and substance?
liquid too.
So it will be liquid, right?
Yes, right.
Okay, number 2.
Number 2, it's dust in air. Medium of dispersion is gas. Dispersed substance is solid.
So it will
Yes,
be solid gas, right?
yes, yes, solid gas.
Right, right. Thank you, Mari. Okay, now
No need.
we are going to move to lesson 2, which is called acids and bases, right?
Right.
Lesson 2, acids and bases. So I think that you studied the simple definition about acids and bases in middle 3, I think, or this part was cancelled. Acids and
I don't
bases.
remember.
I
I
think
don't
that
remember.
no, but what I think in the first in second term, in the beginning of second term, chemical reaction and types of chemical reaction.
Maybe I don't remember.
It's okay. It's okay. Don't worry. We are going to make a revision for this. So listen to talk about acids and bases and what are the differences between them. First, acids and bases play an important role in life, as acids are used in the industry of fertilizers, explosive, medicine, plastic, car motor, and computer. Bases are used in the industry of soap, detergents, medicines, dyes, and etc. So is a product of acids and bases. Okay. Sour
Okay.
fruits, sour fruits as lemon, orange, tomato. Okay. Acids or base forming it from ascorbic acid or citric acid. Okay. Dairy product as yogurt, milk, and cheese from lactic acid. Fizzy drinks from carbonic acid or phosphoric acid. Soup from sodium hydroxide. Washing soda from hydrated sodium carbonate. Baking soda from sodium bicarbonate. So this is a product that we can get it, and this is the sources of this product, both acids or bases. Okay, so what's meant by acid? First, acids, first, a compound with Sir test, compound with Sir test, which turn the color of blue litmus paper into red. So it's a very important property for acid that change blue litmus paper to red. Also, it reacts with metals forming hydrogen. Reacts with metals forming hydrogen. Number 3, it reacts with carbonate or bicarbonate salts forming carbon dioxide gas and water vapor that evolves up. It reacts also with alkalis or bases forming salt and water in a chemical reaction which is called neutralization. I think you studied before that neutralization reaction. It means the reaction between acids and bases to form salt and water. What about the bases? Base or alkali? A compound with bitter test. Okay, bitter test, but bases compound with sour test. And soup texture as soup. When you touch piece of soup, okay, this is the same touch of alkali, which turns the color of red litmus paper into blue, opposite to acids. That acids change blue litmus paper to red. It reacts with acids forming salt and water and is the same property of acids because acids and salts react with each other forming both salt and water. Right?
Right.
Okay, try to read this paragraph, please, Mariam, beginning from acids.
Okay. Acid, a compound with sour taste which turns the color of blue litmus paper into red. It reacts with metal forming hydrogen. It reacts with carbonate or bicarbonate salts forming carbon dioxide gas. It reacts with alkalis bases forming salt and water. Bases alkali, a compound with bitter taste and soap texture, which turns the color of red litmus paper into blue. It reacts with acids forming salt and water.
It's okay. So they are the properties of both acids and bases. Okay, right? Any problem till now?
No.
Okay. So after that, this is about theories. What about theories which define acids and bases? Okay, there are many theories that define acids and bases. As number 1, Arrhenius theory. Arrhenius theory. Okay, as Arrhenius put his theory in late of 19th century to define acids and bases. What's meant by acids and bases according to Arrhenius? Okay, according to Arrhenius. Acids. Arrhenius acid. Substance which dissociate in water producing one or more positive hydrogen ions. Okay, so it's the definition of Arrhenius acid as substance which dissociate in water producing one or more positive hydrogen ions, while Arrhenius base is a substance which dissociate in water producing one or more but negative hydroxide ion. So the difference between them. That's a distinguishing factor between both acids and bases. Okay, as hydrogen, okay, related to acids, while hydroxide related to what? Related to bases. Okay. Okay, Mariam, any problem?
No.
Okay, try to read it again, please.
Okay. Ar Arrhenius,
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 Arrhenius, Arrhenius.
Arrhenius theory,
Yes.
1887. Swedish scientist Arrhenius put this theory in late 19th century, 1887, to define acids and bases as the following. Arrhenius acid, the substance which dissociate in water producing one or more positive hydrogen ions. Arrhenius base, the substance which dissociate in water producing one or more negative hydroxide ions.
Yeah, so it's difference between them. Okay. Any problem now?
No.
It's okay. So let's complete. After that, explanation. As the electric conductivity, as the electric conductivity of aqueous solution of acids and bases is due to the presence of ions in them. So, when sodium chloride dissolves in water, it produces negative chlorine ion and positive hydrogen ion. Okay, so as sodium chloride, okay, as sodium chloride dissolve in water, producing a negative chlorine ion and positive hydrogen ion. It's not sodium, it's a hydrogen chloride, hydrochloride. Okay, not sodium chloride, right? So HCl as hydrochloric acid, it produces positive hydrogen ion and chlorine negative ion. As the presence of positive hydrogen ion, C, it's considered as acid, while sodium hydroxide, NaOH, dissociates in water, producing positive sodium ions and negative hydroxide ion. So, as the presence of negative hydroxide ion, so it's considered as base. And the first to discover the dissociation of acids and base into ions was Arrhenius, as dissociation process has different types. H2SO4 as example, dissociate into H plus HSO4. So it's acid, according to Arrhenius, due to the presence of hydrogen ion. HClO4, it produces H plus ClO4. So as the presence of H, so it's acid, according to Arrhenius only. KOH, it will dissociate into positive potassium plus negative hydroxide. So as the presence of negative hydroxide ion, KOH is considered as base. BaOH by 2 to produce Ba plus 2OH. Also, according to the presence of negative hydroxide ion, so BOH related to hydroxide. Okay, so it's the explanation of Arrhenius acid as in this theory. Acids should contain hydrogen atoms and bases should contain hydroxide group as shown in the previous equation. So the Arrhenius theory helps us explain neutralization reaction and reaction of acids with bases forming water and salts as NaOH plus HCl produce NaCl plus H2O. Right, Mariam?
Right.
Any problem till now?
No.
Yeah, so try to read this paragraph, please.
Okay. From in this theory or remarks on the theory?
No, from the beginning.
Okay. In this theory, acids should contain hydrogen atoms and bases should contain hydroxide group, as shown in the previous equations. The Arrhenius theory helps us explain neutralization reactions. The reaction of acids with bases forming water and salts, NaOH plus HCl equal NaCl plus H2O.
Right. It is very important. Any problem till now?
No.
Okay. So now we are going to move to this part. Okay, try to listen, Mariam, please. The properties of acids and bases.
Properties of acids and bases. When ants sense danger to their colony, they emit a substance called formic acid that alerts the entire colony. Acids dissolved in rainwater hollow out enormous limestone caverns and destroy valuable buildings and statues over time. Acids flavor many of the beverages and foods you like, and an acid in your stomach helps digest the food you eat.
So
Bases
acids in your stomach, as example, acid in your stomach that helps to digest food that you eat. Okay, I think that our stomach, okay, produce HCl acid that kill microbes, okay, and help in digestion process. Okay,
also play a role in your life.
Okay.
The soap you use and the antacid tablet you might take for an upset stomach are bases. Acids and bases are important factors in the chemistry of the environment. For example, different plants prefer acidic compared to basic soils. Rhododendrons flourish in rich, moist soil that is moderately acidic. Sempervivum, commonly called hen and chicks, grows best in drier, slightly basic soil. Physical properties.
okay. So what about the physical properties of both of acids and bases? Listen.
You are probably already familiar with some of the physical properties of acids and bases. For example, you might know that acidic solutions taste sour. Carbonic and phosphoric acids give many carbonated beverages their sharp taste.
So it's the first part that they have their test as acids and bases as carbonic and phosphoric acid.
Citric and ascorbic acids give lemons and grapefruit their tartness. And acetic acid makes vinegar taste sour. You might also know that basic solutions taste bitter and feel slippery.
So, but the properties of bases, solution that their taste bitter and feel slippery.
Think about how a bar of soap becomes slippery when it gets wet. You should never attempt to identify an acid or a base, or any other substance in the laboratory, by its taste or feel. Another physical property of acid and base solutions is the ability to conduct electricity.
So it's very important to note again, and a very important property, that both acids and bases are good conductor of electricity, that they can conduct electricity easily by dissolving in water, as they will produce positive and negative ions.
Pure water is a non-conductor of electricity, but the addition of an acid or base produces ions that cause the resulting solution to become a conductor.
So it's very important to note again that pure water, okay, pure water is non-conductor of electricity. Why? Because I think that the water is good conductor of electricity, and when we touch any machine that conduct with water, so I think that you will shock, right?
Yes,
But why pure water is non-conductor of electricity? Why? Do you know?
because if somebody touched water, he will get shocked.
It's okay. It's
Because
okay. Okay, but
it's
he said in this paragraph that pure water is non-conductor of electricity. Do you know why?
because water is neutral.
No, due to the absence of impurities. Absence of impurities or absence of salts, because it's a pure water. So
Yes.
pure water has no impurities or has no salts, so it's a bad conductor of electricity. But by the addition of an acid or base produces ions that cause the resulting solution to become a conductor. Okay, so there is
Okay.
difference
Okay.
between pure water or salty water. Pure water, bad conductor of electricity because it has no salts or it has no impurities. But water,
Okay.
salty water is a good conductor because it has salts that can dissolve and dissociate easily into positive and negative ion, so become good conductor of electricity. Okay,
Okay.
okay, Mario. So it's the chemical properties of both acids. Watch this video of magnesium reacting with hydrochloric acid. Okay, observe this video. What happens? It's a
It
live react.
dissolves.
Yes, it's a live reaction between magnesium and hydrochloric acid. As magnesium, when magnesium react with hydrochloric acid, it will produce magnesium chloride, and bubbles of hydrogen gas will be produced. As you know, this is called the
Okay.
bubbles.
Yes.
Bubbles, okay. We are going to return it again. Okay. This piece of magnesium,
Okay.
is this effervescence? Considered as
Yes.
bubbles of hydrogen.
Okay.
So it's a chemical reaction between magnesium and hydrochloric acid.
Okay.
Okay, so this is Mg plus 2HCl. Mg will replaced hydrogen. Hydrogen will be replaced by Mg to produce MgCl2 plus H2. Okay,
Yes.
right? So it's from chemical
Okay.
properties. Listen.
Chemical properties. You might have already identified acids and bases by their reactions with litmus paper. Litmus is one of the dyes commonly used to distinguish solutions of acids and bases.
So it's a litmus paper, or litmus paper. Okay, is very property that by which we can distinguish between each both acids and bases. As if litmus paper change it to red, so it will be acid. But if you change it to blue, so be alkali or base. Okay.
Aqueous solutions of acids cause blue litmus
Okay.
paper to turn red. Aqueous solutions of bases cause red litmus paper to turn blue. Acids can also be identified by their reactions with some metals and metal carbonates. Magnesium and zinc react with aqueous solutions of acids to produce hydrogen gas. The reaction between magnesium and hydrochloric acid is described by the following equation.
As we said, it's okay, but magnesium from this.
Watch a video of magnesium.
This is about auto-ionization of water. Okay, it's not important. This Arrhenius model, first model of acids and bases, as Arrhenius.
Okay.
Listen.
The Arrhenius Model. If pure water itself is neutral, how does an aqueous solution become acidic or basic? The first person to answer this question was Swedish chemist Svante Arrhenius, who in 1883 proposed what is now called the Arrhenius model of acids and bases. Many common solutions can be classified as Arrhenius acids and bases. Citric acid, found in fruits such as oranges, fits the definition of an Arrhenius acid. Many drain cleaners contain metal hydroxides, such as sodium hydroxide and potassium hydroxide. These chemicals are Arrhenius bases.
So what's meant by Arrhenius model? Okay, read Maria. What's meant
The
by Arrhenius
Arrhenius
model?
model. The Arrhenius model states that an acid is a substance that contains hydrogen and ionizes to produce hydrogen ions in aqueous solution. A base is a substance that contains a hydroxide group and dissociates to produce a hydroxide ion in aqueous solution.
So it's difference between each Arrhenius acids and bases. Okay. Any problem
Okay.
till now?
No.
Okay. To explain Arrhenius and acids and bases. Okay.
Arrhenius acids and bases. As an example of the Arrhenius model of acids and bases, consider what happens when hydrogen chloride gas dissolves in water. HCl molecules ionize to form H plus ions, which make the solution acidic.
So it's HCl. Okay. By dissolving water to produce positive hydrogen ion and negative Cl. As producing of positive hydrogen ion, so it's acid. Okay, in the opposite direction, NaOH dissolving water produce positive sodium ion and O negative hydroxide ion. As the presence of negative hydroxide ion, so it's considered as base.
When the ionic compound sodium hydroxide, NaO, dissolves in water, it dissociates to produce OH- ions, which make the solution basic. Although the Arrhenius model is useful in explaining many acidic and basic solutions, it has some shortcomings. For example, ammonia.
So I think that each theory has advantage and disadvantage, right? So what about the shortage or disadvantage of Arrhenius theory? Okay, Arrhenius theory didn't explain the presence of ammonia NH3. Okay, didn't explain the nature of ammonia NH3 if it's acid on base, because according to Arrhenius, he said that if if any compound dissociates in water producing positive hydrogen ion, so it will be acid. But if any compound dissociates in water, it will produce negative hydroxide ion, so it will be base. But what about ammonia NH3? What about ammonia NH3, sodium carbonate, Na2CO3? They do not contain hydroxide group, but both they are bases. How? Let's go.
Parenthesis, and H3, and parenthesis, and sodium carbonate, parenthesis, not 2CO3, and parenthesis, do not contain a hydroxide group, yet both substances produce hydroxide ions in solution and are well-known bases. Sodium carbonate is the compound that causes the alkalinity of Lake Natron, Tanzania. Clearly, a model that includes all bases is needed. Lake Natron in Africa's Great Rift Valley is a naturally basic body of water. Water laden with dissolved sodium carbonate from surrounding volcanic rocks drains into the lake but finds no outlet. Evaporation concentrates the mineral, leaving a white crust on the surface and alkaline water.
So this is the shortage of Arrhenius. What about this shortage of Arrhenius? Now let's go to our page remarks on the theory. Number one, polar water molecule contains oxygen atom carrying molecular negative charge, while hydrogen atoms carry molecular positive charge. Therefore, water molecule will be affected by the ions in aqueous solution, one way or another. Scientists discovered recently that protons, positive hydrogen ions, cannot exist freely in aqueous solution. Why? Because they bond with water molecules forming hydronium ions. Hydronium ions. So H or positive hydrogen ion cannot be existed, okay, cannot be existed as ions H. Okay, but what happened? They bond with water molecules forming hydronium ion, which is simple is H3O, right? H3O. So what about the
Okay.
H3O? Okay, try to read this part, Mariam, please, about remark this theory.
Okay.
Polar water.
Okay. Polar water molecule contains oxygen atom carrying molecular negative charge, while hydrogen atom carry molecular positive charge. Therefore, water molecule will be affected by the ions in the aqueous solution one way or another. Scientists discovered recently that protons of positive hydrogen ions
Yeah,
cannot exist freely in aqueous solutions because they bond with
in
water
aqueous
molecules.
solution.
Yes, because they bond with water molecules forming hydronium ions.
H3, all right. So number two, some bases such as ammonia, as we said, from alkaline solution. Also, they don't contain any hydroxide ions in them. So what about this theory? Okay, I think it's a shortage in some idea about this theory. So now we are going to move to another theory or second one, which is called the Bransted-Lowry theory. Bransted-Lowry theory. What about this theory? Okay, formulated their theory about acids and bases as Bransted-Lowry acid states that the substance which lose positive proton or hydrogen ion, and it's called proton donor. What's meant by proton donor? That gives hydrogen or gives a proton. Okay, gives hydrogen or proton. So it's called the Bransted-Lowry acid. What's meant by Bransted-Lowry acid, Mariam?
The substance which lose positive proton hydrogen ion is the proton donor.
Yes, it's called proton donor. What about Bransted-Lowry base? The substance which gains positive hydrogen, okay, gains positive hydrogen or hydrogen ion, it's called the proton acceptor. So it doesn't mean by the presence of hydrogen ions or hydroxide ions, as Arrhenius said, but it depends on the proton or ions that either donor or acceptor. Proton donor, it's called the Bransted-Lowry acid. But proton acceptor, it's called what? It's called ايش? Bransted-Lowry base. So according to this theory, we can say that the acid is a substance that gives proton to base, and base is a substance that takes proton from acid, which means that the reaction is the transfer of proton from acid to base. In the summary of this theory means that the reaction is the transfer of proton from acid to base. As example, this is a general example. A as acid plus Hb, okay, Hb as base, according to A is considered as acid, so Hb will be base. To produce Ha, so H, it's base, okay? Why base? Because it will be acceptor, it will be proton acceptor to be Ha, right? Ha will be said as or will be defined as conjugate base, conjugate base, while B will be said as conjugate acid. So we have acid, base, conjugate base, and conjugate acid. Again, what's the difference between them? A, it's called acid. So the other compound will be base because will be proton acceptor. After losing this proton, so acid will change into conjugate base. So acid will change to conjugate base, and base will change to conjugate acid. Okay, Mariam?
Okay.
So when an acid loses a proton, when an acid loses a proton,
Yes.
it turns into conjugate base. Okay,
Okay.
as acid loses a proton, so can be changed into conjugate base. What is when base gains a proton? It turns into a conjugate acid, right?
Okay. Right.
So try to read this paragraph from the first. Bransted-Lowry base.
Okay. Bransted-Lowry base, the substance which gains positive proton, hydrogen ion, and it's called a proton acceptor. According to this theory, we can say that acid is the substance that gives a proton to base, and base is the substance that takes proton from acid, which means that the reaction is the transfer of proton from acid to base. When an acid loses a proton, it turns into a conjugated base, whereas when a base gains a proton, it turns into a conjugated acid.
You're right. So what's meant by conjugate base and conjugate acid?
Conjugated base is the substance formed when an acid loses a proton. Conjugated acid, the substance formed when a base gains a proton.
Right. So when we dissolve HCl in water, hydrochloric acid solution is an acid because HCl gives a proton to water. Therefore, water is considered as a base. So, water in this case will be base. Why? Because HCl loses proton. Okay, loses proton. So HCl must be acid and change into conjugate base, while water in this case will be base. Okay, as therefore water is considered as base because it gains proton from HCl, right? So ammonia is considered as Bransted-Lowry base because it accepts proton. Okay, it accepts proton, or
Okay,
called proton acceptor from compound, right? Try
right.
try to explain by another way. Explain Bransted-Lowry by another way. Okay, try to listen, please.
Okay.
The Bransted-Lowry Model. Imagine a father and son playing catch. The simple action of tossing a ball back and forth can serve as an analogy for a second acid-base model, the Bransted-Lowry model. In this model, the key is whether a molecule will donate a hydrogen ion or accept a hydrogen ion. Acids donate hydrogen ions, while bases accept them. When the father throws the ball, parenthesis, a hydrogen ion, to his son, the father is like a Bransted-Lowry acid and the son is like a Bransted-Lowry base.
Why? Because the father is like a Bransted-Lowry acid because it becomes donor or acceptor for this ball. Father will be donor or acceptor, Mariam.
To his son,
Yeah,
he will be donor,
yeah, will be donor. While his son will be what?
acceptor.
Acceptor. So this father can be called as acid according to Bransted-Lowry because it gives hydrogen, while his son considered as Bransted-Lowry base because it accepts hydrogen or accepts this ball. Right? This example.
The
Yes,
son then
right.
becomes the acid because he has the ball, parenthesis, a hydrogen ion, to give away, and the father becomes a base because he is available to accept the ball, parenthesis, a hydrogen ion. You can think of a game of catch as an analogy for the Bransted-Lowry model of acids and bases.
Okay, so this Bransted-Lowry basis as Bransted-Lowry model, okay, a model of acids and bases in which an acid is a hydrogen ion donor and base is a hydrogen ion acceptor. It's the meaning of Bransted-Lowry model generally. So what's meant by Bransted-Lowry model?
A model of acids and bases in which acid is a hydrogen ion donor and base is a hydrogen ion acceptor.
Right. Any problem till now, Mariam?
No.
So by this way, it's as simple as HX generally. Okay, HX as HCl plus H2O. It will produce what? Producing H2O that accepts hydrogen to be H3O. So H2O accepts hydrogen to be H3O plus X negative, okay, plus X negative. So by this way, HX called what? Acid or base?
It's an acid.
Acid. While X will be what?
A base.
No, conjugate base.
Wait. Yeah, a conjugated base, yes.
Yes, while H2O that will accept
Is a conjugated,
hydrogen
yes,
considered as what?
as a base.
Base, while H3O as
Is a conjugated acid.
right. Excellent, Mari. Conjugate acid. Okay, so by this way, H3O plus X negative can be returned back again to be HX plus H2O. It's about Bransted-Lowry. Conjugate acids and bases. Okay, what's meant by conjugate acids and bases? Okay, first, this is called conjugate acid. What's meant by conjugate acid, Mariam?
The species produced when a base accepts a hydrogen ion from an acid.
Right, so they are called as species produced when a base when a base accepts hydrogen ion from an acid. So accept when a base accepts hydrogen ion, it will change into conjugate acid, right? So
Right.
by this way, what's meant by conjugate base?
The species produced an acid
Yeah,
um, when an acid loses a hydrogen ion.
not loses or gain. It's called gives.
Okay.
Gives what?
Gives a hydrogen ion.
Gives a hydrogen ion, okay, from this. Add this conjugate base by this way.
Yes.
Species produced when an acid donates or gives a hydrogen ion to base. So it will be conjugate base. And the difference between each
Okay.
conjugate acid and conjugate base. All right? By this way.
Right.
This is as what? Acid, okay, by this equation, HX plus H2O to produce H3O plus X. So HX called what?
An acid.
While X after losing hydrogen
Yes.
be what?
A conjugated base
Right. So what about conjugate? What about the second paragraph? H2O in this
is a base.
part will be as a base. So H3O
Is a conjugated acid.
conjugate acid, right? So it's difference between both acids, conjugate acids, bases, and conjugate base. Okay, Mariam, any problem till now?
No.
Right, it's a Bransted-Lowry. So it's the explanation of this compound as hydrogen fluoride. Hydrogen fluoride HF. So HF and H2O. HF and H2O. Okay, HF will produce what?
HF will produce only F.
Only F or only H? Only F or N or only H?
It will be only F.
No, it will produce H, as it will be donor of hydrogen ion, not F. Why
Yes.
F? So why F? Why you
No,
said F?
I mean end. It
Yeah,
will
yeah, yeah,
be
yeah, yeah.
H.
You mean that
O
it
plus
will
F.
change into F?
Yes.
Right,
Yes.
right, right, right. Okay. So HF considered as acids or bases.
As
HF,
an acid.
it's an acid. So as HF is an acid, so H2O will be
A base.
base, right? So H3O will considered as what?
A conjugated acid.
Right, excellent. Conjugate acid. While F only turns to what?
Conjugated base.
Conjugate base, right. This is the example of hydrogen fluoride according to Bransted-Lowry acids and base. Any problem?
Yes.
As this.
No.
HF acid, F only conjugate base. While
Yes.
H2O base, while H3O conjugate acid. Any problem?
No.
What about the ammonia? By the same way as ammonia,
Okay.
NH3, NH3, okay? But there is
Okay.
difference. There is difference between them. There is difference between the action of water in these two equations. Water, when it reacts with HF, water became solid, became acid or base?
With HF,
With
it
HF,
was a base.
with a base, right?
It was a base.
But in this equation, H2O
It's an acid.
will be acid. Why? Because in this way, okay, H2O will produce H or gives hydrogen to ammonia. And in this case,
Yes.
H2O will change into OH, while NH3 will change into NH4. So by this way, H2O called acid or base in this example,
Acid.
while OH,
Conjugated base.
right, NH3 called what?
Base.
While NH4,
Conjugated acid.
right, excellent, Maria. So this is a problem by this way. H2O will be acid, while OH will be conjugate base, and
Yes.
NH3 will be base, while NH4 conjugate acid. Okay, Mariuma,
Okay.
any problem till now?
No.
So this is a Bronsted acid slowly with water. So water is called what? Water is called what?
Water.
Yes, amphoteric.
Amphoteric.
Yeah, amphoteric. This is a new word which is called amphoteric. What's meant by amphoteric? Try to
Describes water. Yes. This describes water and other substances that can act as both acids and bases.
Yeah, so describes water and other substance. There are another substance that can be called amphoteric. Amphoteric. Why amphoteric? Because they can act as both acids and bases. Okay, according to the other substance that will make reaction with it. As water,
Yes.
acts as base in the in HF in this reaction, while the same water acts as acid but in ammonia. So it's called amphoteric. It's called what? Amphoteric.
Amphoteric.
Right? Any problem till now?
Right. No.
Okay, Mario. Okay, so let's return to our page as conjugate acid. Okay, let's complete Louis theory, or in the next session, what do you need?
It's late, to be honest.
Okay, it's very easy
If
to
you
complete
want
it.
to,
Yeah, okay, okay, too. So Right, so try to complete it. Don't worry. To finish the three theories about acids and bases, okay?
Okay.
But no problem for you.
No problem.
It's okay. Lewis theory is the third theory about definition of acids and bases. Scientist Gilbert Newton Lewis formulated a more comprehensive theory about acids and bases, which states that what's meant by and what are the differences between both Lewis and Lewis acids and base. Lewis acid, substance that receive one or more electron. So it will treat as electrons, not protons or hydrogen. As Arrhenius said, transfer of hydrogen. So it will be acid, or transfer of hydroxide, okay, will be base. While Bransted-Lowry said that substance that gives or donate hydrogen, it will be acid. But the other substance that will accept this proton or hydrogen will be is called acceptor and called base. According to Lewis theory, acids is the substance that receives one or more electron, while Lewis base the substance that gives away one or more electrons. Right? So it talk
Right.
it talk about what? Talk about electrons, transfer of electrons, not protons or hydrogen. So
Yes.
when a positive when a positive hydrogen ion H binds with negative fluorine 1, okay, so hydrogen ion is regarded as Lewis acid because it gives away electron, while the fluorine ion is regarded as Lewis base because it takes electrons. Okay, so
Okay.
hydrogen ion as a Lewis acid because it gives a hydrogen, it gives away electron, loses electrons, while the fluorine Lewis base because it will take this electron. So it's difference between each Lewis acids and bases. Okay, try to explain
Okay.
this theory by another way. Lewis model.
Okay.
Okay, listen.
Okay.
The Lewis model. Perhaps you will not be surprised to learn that an even more general model of acids and bases was proposed by American chemist G. N. Lewis, parenthesis, 1875–1946, and parenthesis, recall that Lewis developed the electron pair theory of chemical bonding and introduced Lewis structures to keep track of the electrons in atoms and molecules. He applied his electron pair theory of chemical bonding to acid-base reactions. Lewis proposed that an acid is an ion or molecule with a vacant atomic orbital that can accept, share, an electron pair. A base is an ion or molecule with a lone electron pair that it can donate, share. According to the Lewis model, a Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor.
So
Note that the
what's
Lewis model
meant?
includes all the sub.
So Mariam, what's meant by Lewis model?
A Lewis acid is an electron pair acceptor, and the Lewis base is an electron pair donor.
Yes. So Lewis acid, electron acceptor, while Lewis base, electron donor. Right?
Yes. Right.
Okay. Okay. So by this as HF, to explain the HF, consider the reaction between hydrogen and fluoride ion to form hydrogen fluoride molecule. The role of electron pair is illustrated through the following Lewis structure. As H ion is called as Lewis acid, it vacant first orbital accepts one electron. It accepts one electron, so it's called Lewis acid. while HF called Lewis base. Okay, so fluoride ion is the Lewis base. It donates the ion electron pair to form hydrogen fluoride. Okay, so H in this case or in this reaction acts as Lewis acid because it accepts electron, while F acts as Lewis base because it donates electron to F, to BHF. Okay, so Lewis theory explained this reaction about H and F. Okay, and also this reaction between NH3 and BF3. Okay, NH3 and BF3. Okay, it's called Lewis acid. Lewis acid, why? Because it will accept electrons from nitrogen, while ammonia in this reaction called Lewis base because it gives electrons. Okay, so after that, finally it will be by this formula. Okay, and also this another example about Lewis acid and Lewis base SO3, okay, plus S to produce SO4. Okay, Mariam?
Okay.
Any problem till now, Mariam?
No.
Okay, so I think that we finished this lesson, and I think you are sleeping now, right?
Not really,
No,
but
no,
I'm
no,
going.
no, really, no, really. I know that because it's a chemistry session exactly after biology session. So I think that your brain
I had 2 hours
became
of biology
tired.
today.
Yeah, what?
I had 2 hours of biology today. I
Two
only took today,
hours.
so
Oh my
it's
God, 2 hours biology.
yes.
2 hours biology and 1 hour from Mr. Ahmed chemistry. I think that you became tired. Yes, right?
Yes.
Okay, Mariam. Okay. Thanks, Mariam, for your presence. Okay. And I hope that this session, I hope that you enjoyed from this session. Okay.
Yes.
See you later, inshallah, Mariam. Okay.
Sure.
See you later, inshallah. And